Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS and we have been covering the topic sampling techniques in which we started probability proportional to size, in which we have done PPS WR, probability proportional to size with replacement, and in today's lecture we'll be covering the topic PPS WOR, probability proportional to size without replacement. So in PPSWR, we saw that we took Z statistics. If we talk about PPSWR, probability proportional to size with replacement. So here we took the Z statistics, which was nothing but Yi upon NPI for all i's. So what we did was, I goes from 1 to n. So what we did was, we took one sample from the proportional probability proportional to size from the population and then replaced it in the population alone again, and so the probability of selection of a unit I remained constant, which is pi. But in without replacement case, if we select a sample from the population, if we select a unit from the population, then we'll not replace it, we'll take it out only, and by this measure our probability changes and hence our estimation also changes. So we can say that in PPS WOR, probability proportional to size without replacement, the expectation of Yi upon NPI changes with successive draw. This changes with successive draws, and hence the variant probability, and hence make, and thereby, since we have to calculate individually for every sample unit, this method becomes complex. So thereby making very probability sampling technique a not a complex. So if we have to take out every expectation from every unit, then this probability sampling techniques becomes more complex. So what are we going to do now to overcome this difficult situation? I am telling you what we have to write in the theory as well, so you can note it down. To overcome this difficult situation, we associate a variable a new variable with each draw. We will associate a new variable with each draw, and such that its expectation is equals to the population mean. So these set of new variables, these set of new variables are known as ordered estimates, and this method was founded by Desraj, and hence the method is known as Desraj method. So Desraj ordered estimates or Desraj method. So we'll be discussing with Desraj method. So starting with Desraj ordered estimates. Right? So for that, first of all, we'll take the notations, important notations. First notation is UI. UI is the ith unit. For all I goes from 1 to capital N. This is our UI. Then the second is PI, which is probability of selecting ith unit. Again, I goes from 1 to capital N. And we also know that one of the thing that if I goes from 1 to N, PI, if we sum over PI, then we'll get 1. Obviously, all the probabilities should be equal to 1. Now, taking another thing, just PI1. This is probability of selecting ith unit in first draw. Now, since we know that here also for all I goes from 1 to N, we know that we are talking about PPS WOR. In PPS WOR, the probability of selecting ith unit will be equal to PI only. So we can write it as probability of selecting ith unit in first draw. In first draw, any selection of any unit will be PI. Okay. Now the second one, probability of selecting ith unit in rth draw. Probability of selecting ith unit in rth draw. Again, this goes from I goes from 1 to N. Now probability of selecting ith unit in second draw. Probability of selecting ith unit in second draw. For all I goes from 1 to capital N. Now probability for selecting ith unit in second draw, this can occur in following ways. The occurrences, if we have to select the ith unit in the second row, let us select u1 is selected in first row and ui is selected in second row. First case would be this one. The second case would be u2, second unit is selected in first row and ith unit again is selected in second row. Going on further, ui minus 1 is selected in first row and ui is selected in second row. Then ith is already selected in the second row, so we'll take ui plus 1 is selected in first row and u and ui is selected in second row. Now carrying this again, we'll get un is selected in first row and ui is selected in second row. So these will be the cases if we say that the probability of selecting the ith unit in second row. So this can be written as p I can be written as probability of selecting 1 into 1 minus probability of 1 into p1. Probability of selecting ith row in the second term right, probability of selecting the ith row in the second term, and then it would be the probability of selecting the first unit in first row will be p1, and probability of selecting the ith unit in the second row will be pi upon total probability becomes 1 minus p1, because we are discussing the case of PPS WR without replacement. So this one will be this is for first one. Then the second one will be probability of selecting of second unit first and probability of selecting of ith unit in second row. So it will be 1 minus p2. And similarly, probability of selecting of I minus 1th unit first into probability of selecting of ith unit into 1 minus probability of selecting of I minus 1 unit. Similarly, we can write that probability of selecting of I plus 1 unit first and probability of selecting of ith unit in the second row, and it would be 1 plus I. Similarly, going on further, probability of selecting of nth unit first into probability of selecting of ith unit in the second row upon 1 minus pn. So this would be our probability. We can write it as summation j goes from 1 to n pj into pi upon 1 minus pj, where I is not equals to j. We can write it like this. For all I goes from 1 to n. Why is I not equal to j? If we select ith unit first, then it is not replaced. So we cannot select ith unit the second time. Suppose we have 5 samples, p1, p2, p3 and p5. If I select p1 first, then I am not replacing it in the sample. So I am left with p2, p3, p4 and p5. I have to select from the rest of the that one. So I is not equals to j comes from there. We can write it as summation I not equals to j goes from 1 to n pi pj into pi upon 1 minus pj. Let us add and subtract pi upon 1 minus pi minus pi into pi upon 1 minus pi. If we take this inside summation, we'll get summation j goes from 1 to n pj to pi upon 1 minus pi minus pi into pi upon 1 minus pi. This would be pj. We can take pi common, so we are left with pi summation j goes from 1 to n pj upon 1 minus pj minus pi upon 1 minus pi. So this will be our probability that ith unit is selected in the second row. And similarly, we can carry out probability of ith unit selected in the third row and fourth row and so on, making the table like this. So as you can see that this is a more complex method, and this requires a lot of time and efforts and varying things. So the Sraj estimator is a short form or is a much less complicated version of this, which we are going to discuss in the further class. It is the method of estimation like we did in PPS WR of cumulative total sum and Lahiri's method. It is similar to similarly this is the method. The Sraj method is the method for estimation with the PPS WOR. Now one more thing is there. Then here in PPS WOR, we see that estimation of only y1 upon np1 is equals to y bar, which is population mean, and it estimation of yi upon npi is not equals to population mean unless for all I goes from 2 3 up till so on, not for 1. For 1 it is equals to the population mean, and for the rest of that it is not equals to the population mean, and hence comes our this Raj method, which we are going to discuss in the next lecture, which is very important, has been asked ample number of times in the PYQs. So I hope that whatever we have done today meant to be clear your basic on this, and has been asked many times in the exam as well. So it is important from the exam point of perspective, and I hope that we have done things clearly today, And if you have understood, well and good. No, if you haven't, then you can ask in the comment section or on WhatsApp channel. Only relevant doubts will be answered. And keep on working hard and keep on asking your doubts as you have been asking in the recent times. All the best. Thank you.